Okay, welcome to the next session. Our first speaker is a little bit different order than planned before. We put first Damien giving his presentation, then there's Peter remotely, and then as last speaker Erik. So please, Damien, from Finnish Computing Center.
So yeah, my name is Damien Lecarpentier. I'm from CSC IT Center for Science. It's the Finnish National Supercomputing and Data Center. I'm also leading a European initiative called EUDAT, which is building a network of supercomputing and data centers to create a European data infrastructure. And I'm involved in many various EOSC initiatives. So I thought I could maybe give an overview of the FAIR-related activities in EOSC, and hence the title, How FAIR is EOSC? I'm going to talk about what's existing now, but maybe more interestingly about what's in the pipeline, because there are some initiatives that, although they are not funded yet, are coming. And so we will see how what we've been discussing this morning will materialize in concrete projects. So when looking at EOSC and FAIR, I mean, we're talking about two different things, but still they have a link, and they've been running at a very fast pace, I would say, especially in the European Union. The FAIR initiatives, also it dates back a bit, a couple of years earlier, but I think the publication of FAIR principles was only done in March 2016, and since then, I mean, 2 years for imposing such an acronym and such a concept, such a revolutionary approach to open science is very short. And it's interesting to see how FAIR has been progressively penetrating EOSC. So March 2016, you have the publication of FAIR principles. April 2016, it's a big milestone in the European Open Science Cloud. It's the European Union communication on European Cloud Initiative. It's the founding authoritative paper of the European Open Science Cloud. It's in this communication that is laid down the principle of a European Open Science Cloud. And here you have the first mention to FAIR, and it's a small reference. It's about data products from Edge 2020 should be open by default, and then in brackets, according or in line with the FAIR principles. So it's a suggestion more than a requirement. Then we have the beginning of EOSC implementation with some first projects. That's the EOSC pilot, which is about governance, policies, trying to engage the stakeholder community. Then we have the second big paper on EOSC. It's the EOSC Declaration. And there, the reference to FAIR becomes a bit more pregnant. I think here you have like one reference here. You start to have like 30, 35 references to FAIR, and you can see that it's really penetrating the lexicon and all the phrasing of the European Open Science Cloud. Here they say the same things. Research data should be open by default and supported by FAIR data principle. It's not just anymore a reference, but it is a requirement. You also have some discussions about rewarding researchers that are complying with FAIR principles, making FAIR principle part of day-to-day research data management. So that's the first big progress in what, about a year and a half. And then things from there develop rapidly. You have the EOSC implementation roadmap, and here we come to 80 references to FAIR data, and then FAIR principles are set as key cornerstones of the European Open Science Cloud and the implementation roadmap, to the point that they become a kind of okay, if you want to take part to EOSC, you need to be fair. So we've moved in a year and a half, 2 years, actually 2 years, from a reference to fair principles to a requirement to be fair compliant if you want to take part in EOSC. And then we had a few other projects that got funded, and what Simon presented this morning in the Fair Data Action Plan. So it's a moving thing. If we are doing the same workshop in 2 years, well, we'll see how it has evolved. But we are just at the beginning. An action plan, by definition, is something to make something happen. But we are really still at the planning phase. So, but what's interesting to understand is what is behind FAIR, what is behind EOSC, and how the two can work together. And this is not as simple as it might look on this slide. What I very much like in the FAIR approach taken by the various expert groups that have tried to articulate the principles is to view FAIR as an ecosystem. I think this is very, very important. There is this approach, I mean, is very pregnant in the high-level expert group on FAIR data, where they distinguish various components of the FAIR data ecosystem, the policies, the identifiers, the repository standards, and so on. There's been other development that have really insisted on this aspect, that if you want to approach FAIR, address FAIR, you need to approach it from a holistic perspective. Also in the high-level expert group report, very important things on the technical infrastructure supporting FAIR, not just about policies, not just about standards and ontologies, but you need to plug in all your storage and computing infrastructure to support that part, this approach. And then last but not least, a FAIR culture. It's really about changing, sharing data management practices and research culture around data management. So FAIR is complex, but so is EOSC, because we see EOSC as one big thing, but it's made of multiple actors and multiple projects, and this is the projects that are coming up and that will go live next year. Big projects, a few million euros per project, focusing on governance, implementation, and community. And so it's the multiplicity makes it quite challenging also to move in a coordinated way, because this is not just like this is not the commission that is behind this. These are different consortia, different research communities, and they are a bit independent and autonomous, and we have to deal with that complexity. Few words on current infrastructure project. I mentioned EOSC pilot. They've been working on a number of things, a bit on interoperability, a bit on metadata, with an attempt to create a minimum metadata model. EOSC Hub, which is also a project where EUDAT we are very much involved, looking at the more low-level infrastructure, trying to build some common metadata and service catalogs, trying to foster a culture of data sharing through the use of PIDs, metadata, DMPs, AIs across research infrastructures. And this is, okay, this might sound quite simple for those who are working with data, but I can assure you that many of our users of big supercomputer and big machines, they are not yet into this data management approach. They are not thinking in terms of PIDs, metadata, and so on. So our role is try to to educate these people to try to make the data move from the private domain to the registered domain where it can be shared and then later published. And also you have some work in open air on training and support, fair data monitoring, fair data management plans, and so on. This is where we are now. It's not much. I would say we focus more on the F of FAIR, the findability, discoverability, with metadata identifiers. Focus a bit on the on the access with AI, on the R with reuse, with the licensing things, but not so much, I would say, on the I, which is maybe a bit more domain specific. There's as I said, a set of projects that are coming up and that will go live starting this year, and that you have to pay attention a bit because that's where the implementation will take place. So I'm gonna present a few examples. A big disclaimer, things that I'm presenting are not yet funded, officially approved, so I'm being cautious about presenting them just as ideas, not as funded projects. But they've been answering the different calls that have been launched by the European Commission. We have a first thing on S-freeze, another thing on fair data tech and compliance, and then something about coordination of national initiatives. I think the maybe the biggest call is related to S-freeze. So S-freeze are the strategic research infrastructures in the European Union, and they are gathering through clusters. So you have an S-freeze for environmental science, for physics, for life science, and for social science and humanities. And they are answering a call that is really bringing FAIR at the center of these projects by asking them to work according to the FAIR principle, to define domain-specific data policies and build the relevant tools to support FAIR. A few consortia ideas that have appeared. They're building on existing works. Ari has presented something related to ENVRI community and the ENVRI FAIR. So they're going to work on common policies for environmental data. They want to try to assess fair practices and develop fair compliance services. I understood also that the communities are quite heterogeneous, so they want to address things at the subdomain level for atmospheric, marine, solid earth, science, biodiversity. And then train the people and the personnel in the research infrastructures to work along the FAIR principles. We have similar things in the photon and neutron community, and that tells you that it's the whole spectrum of research infrastructure and science that is that has been caught by the FAIR syndrome, and these guys are also trying to bring their partners at a common maturity level, also working on common data policies. They want to address the 4 dimensions of FAIRs by looking at DOIs, enriching metadata, common APIs, and so on. So that's what the photon and neutron community want to do, and many big data analytical facilities. In social science and humanities also, they are working on embracing the FAIR aspect or approach by developing common standards for metadata across the community, focusing on ontologies for social science and humanities. They're also interested in working on sensitive data and how sensitive data can be FAIR compliant. and also providing tools and services for supporting FAIR. Astrophysics and particles, again, dealing with extremely large volume of data, how to make this data FAIR compliant. They want to develop a common set of rules for managing the data, building on the virtual observatory infrastructure, how to enable a federated storage infrastructure, and manage the competence. There are also other discipline clusters in life science. I didn't mention that here, but there are many consortia that are forming up to embrace this FAIR. Another important initiative that is in the pipeline is related to FAIR uptake and compliance in all scientific communities, but is a bit overarching the whole thing, and try to propose a framework to develop some certification, verification of repositories, and manage competence regarding FAIR. That's a consortia that is also forming, and that is called FAIR. Not funded yet, but these people have some ideas of what they want to do together. They want to work on FAIR certification. We've been mentioning Core Trust Seal this morning. This is the baseline for discussing FAIR certification. So they want to develop some badges for Core Trust Seal certified repositories as a first step towards the certification. Working on a capability maturity model. That is, I think, very important because there is some heterogeneity in terms of where repositories, organizations stand with regard to fairness. So by doing this or developing this maturity model, then it offers also guidance to people to understand what kind of how they can develop towards greater fairness. And we mentioned that this morning about data quality. FAIR certification at the moment does not really address this topic per se. You could be fair and having data that is of a questionable quality, and there are some discussions about extending the FAIR certification and trying to measure some data quality. Something that is also that I see increasing in the discussion of FAIR it's that FAIR is not just about repositories, data, but it's also about services and software. So this consortium want to develop recommendations for software for assessing the fairness of services, which raise different issues regarding interoperability, regarding management aspect of services. So we have to address the topic in a different way, and then try to understand also the difference between services that would be fair because they comply to FAIR principles, or services that are just fair because they are supporting FAIR data. And then something about culture, developing a data competence framework, and university curricula. Very ambitious task, university curricula and courses, and here we'll be working with the European Union Association, which is a European University Association, which is a network of universities. Talking to different stakeholders is very fundamental to address FAIR. And the last set of projects is related to coordination of EOSC relevant national initiatives. The call is not yet open, or it is open, but there's no proposals that have been submitted. But just to tell you that at national level also there will be some actions that are trying to promote and support the uptake of FAIR across the different disciplines. Okay, some concluding remarks. I could have said that first there's a rapid evolution. I mean, in a two-year time frame, very much has happened, and there is a strong positive push from the European Commission, but also backed by European member states, towards turning FAIR into a key component of EOSC. This is there. This will happen. The good thing is that the proposed approach is comprehensive. It addresses all dimensions of the FAIR ecosystem. It talks about policies, tools, culture. It's not just about one of the dimensions, but it's rather holistic. There's a positive commitment and enthusiasm from multiple stakeholders, researchers, research infrastructures, policy makers. They're all involved, both at national and European level, and FAIR is on everyone's agenda. This is really true for what concerns Europe, and there are some budget lines to accompany this implementation. Of course, you always say that it's never enough, but and it's true. And I think Michel was addressing this question of how much does it cost to be FAIR. It might be one of the questions that is on the table in the next month or years. We'll see that. But that's very that's a very rapid progress. And just to conclude, some upcoming challenges that I see while looking at what's happening in the various areas. I think we have a fundamental challenge, which is how to coordinate and align these various initiatives to turn FAIR into reality for EOSC. At some point, I mean, it's good to have like multiple project initiatives, but at some point, someone will have to turn this into a real implementation. We need to make sure that the developments of clusters are in line with one another. At the moment, FAIR is on the agenda of all the research communities, but we're not quite sure that we're talking about the same thing. So we need to align a bit this development, but there's no reason why this would not happen. Also, try to make sure that the European initiatives are well articulated to national and global initiatives. That's very important. And something we started to discuss this morning, we need to stabilize a bit the EOSC final architecture and focus. At the moment, there are some discussions about what it should be, how it should develop. And here, and that will be my conclusion in form of a question, is that FAIR could actually be the primary driver of EOSC developments. By working on FAIR, you are making EOSC basically, rather than the other way around. So how EOSC is supporting FAIR? This is usually the question we were discussing. But how FAIR is supporting EOSC is, I think, equally important. And here, I think the transition is already made with next speaker and Go FAIR. That is working on some concrete development and implementation that could be also taken up for turning FAIR into a reality and make it a cornerstone of EOSC. And that's it.
We have chance for some questions or comments, please.
Small question. We know that some money should be paid to be FAIR. This is to lose money. The second side, what will we get? We understand that what will we get should be bigger than what will we pay.
Yeah.
Could we see in more detail, more clear picture?
Yeah.
I know that this is bigger, but we
Yeah, so we should, that's a very interesting question, the cost of not making data fair.
Yes.
And I think here you're running the risk of losing visibility and also reusability of your data. If you're not buying the fair concept, then you might, like it's a bit living in or having data in a dark archive where it's not really discoverable, people cannot reuse it, and then you're losing money because you've invested a lot in data that maybe is not achieving its full potential. So, but I'm not aware of any studies on the cost of not making data fair.
So in fact, at the RDA meeting in Berlin, just a few months ago, there was the EC sponsored a section precisely on this question, the cost of not going fair for Europe. And I think the EC hired PricewaterhouseCoopers consulting to do this analysis. And the funny thing was, in that they mentioned at that time how much it would cost to not go fair. Then came the next question, well, how much does it cost to go fair? And they were still working on that. They didn't have the answer yet. But it was 11.4 billion annually for Europe.
I noticed in our infrastructure, in some of the key documents, we will be fair, but necessary steps, how much necessary steps should be prescribed?
Yeah. So this
on
is
the initial stage, we prescribed nothing.
yes.
We only told that we are
We're lacking the implementation part. We're big on saying let's be fair, but then what it means is a bit more pragmatic, and especially at the political policy level, it's easy to say let's be fair. When you talk to repository managers, wow, it's not that easy. So we need practical tools, capability, maturity models, and all these things. But we don't have these tools or all these tools yet.
I have two questions. First of all, why do you say about the certification of measured data and didn't say about the computed data?
This?
Will you do the certification of computed data, not only measured data?
No, I didn't say.
It's not problem for the.
I'm not sure what you're referring to. I didn't make a distinction between computing.
I will give example. For spectroscopy, the volume of the measured data is a few, approximately 4 orders less than the computed data. And for this science,
Simulated.
Okay, I think there's a misunderstanding. I didn't talk about measurement data. I talk about.
Maybe it's an observation versus simulation. Am I right?
No.
What? Yes. So,
It's for measuring data quality. It's not about measuring data. It's all data.
So I can say there's been some discussion also in the last, I'd say, year about FAIR and its relation to the core trust seal, because there is certainly some overlap, but there's also places where there are repository level responsibilities that are not necessarily directly related to identifiers or to persistence of metadata. So I think now with the core trust seal, we're trying to start pulling apart exactly what the repository core trust elements are from the computer actionable FAIR components. And what's driving that discussion is that the core trust seal now is a certification program that's very manual, human intensive. So it won't scale. It can scale for repositories maybe, but not for just data in general. So there's also these FAIR metrics that are designed to be more actionable, more computer-based, so that you can scale more readily.
thank you. And the second question is, can you say us about the principle of organization or implementation
The organization. So the idea with this this project, which is pushed by a number of partners that are very active in the trusted repository domain, is to build a network of trusted repository by having them certified core trust seal. That's the whole idea at the moment. There are a number of repositories that are already certified, actually many, and it is to extend this number by also offering them concrete support and guidance to make their repositories trusted and certified.
Okay, I think we need to move to the next one. I'm a little bit confused. Is the next one Peter or?
Yes, I think so.
Okay, in that case, I trust the organizer.
So, Peter, are you with us?
Yes, I'm here.
Okay.
And
So
you can hear me?
according to our timetable, the next talk is yours, sir.
Yeah, thank you. So, dear colleagues, workshop colleagues,
Peter,
my name is, as you can see
excuse me.
perhaps on the slide, Peter Wittenberg. I'm from the Max Planck Society. I was a data scientist. It wasn't cold like this 3 years ago, and I worked in the area of brain research. Recently, I worked in the e-science facility of the Max Planck Society. Before I go into my talk, I would like to make a few statements from my side, remembering Leonid. Right, so let me start saying that I should be in Moscow with you, and as you can hear in my creaky voice, I was very much frustrated on Saturday to find out that I had a severe cold and lost almost my voice on Sunday, but now, as you can see, I'm recovering. So a few years ago, I suddenly got an email from an, at that time, unknown person to me to give a keynote at the first DAMDID conference in Obnitz. Of course, as you can imagine, I first had to look, whether Obnitz is a fake or something real, but thanks to Google Earth, I found out that Obnitz is indeed a place south of Moscow. After some interaction with Leonid, I agreed to come and started to produce my keynote paper in interaction with a very demanding person. Leonid wanted to know a lot from me about the work we do in the Max Planck Society, about the infrastructure work which I was responsible for, and about the Research Data Alliance. And as some of you who know Leonid will know, he was never satisfied, completely satisfied. So I had to do a lot to really make him satisfied. Well, when I came to Moscow, finally, I met a very gentle person and an utterly knowledgeable and serious computer scientist. We kept in contact after this event, since I think we both were seeing the dynamic developments in data science and the need to continue interactions and debates. And we both saw the different approaches which we had in our network. So the more pragmatic approach from people like me in Western Europe, and the more computer science approach in Russia. And they are complementary as far as I can see. We both felt also the need to continue the interactions, I would say, in times which are politically not at all simple. So therefore, I was very grateful when Leonid took the initiative to organize this workshop in Moscow, and I promised Leonid to take care of getting excellent experts to Moscow to present and discuss the EOSC and FAIR related issues. Well, of course, with Leonid having passed away, I lost a serious partner to talk about data science matters. But I hope we can continue these interactions in his spirit. For me, this means really that after having heard Sergei's and Nikolai's talk, that I will take serious work to see how their work of interoperability, integrating, can fit with the work which we are doing, which present in the short, and which all has to do with FAIR and EOSC in some way. But I also hope that many more of you guys from the Russian community will be involved in our discussions. I think this is very much needed and would be very welcome. Now let me turn to my talk, and still some moments to go.
Peter,
So what I will do,
Peter,
yeah.
you have now about, let's say, 20 minutes time.
Yes, I know. So it's about introducing the concept of digital objects. And as you will see, it's very much related to FAIR and EOSC. And I would also say there is a relationship between what Sergei and Nikolai presented, much less ambitious than what they two said. And all these things emerge in the Research Data Alliance. So let me share a few ideas from a completely different view, which has not been raised today. So if you look at internet development steps, and I took this a bit from our American colleagues who developed the internet, you could derive some phases, right? So originally there was the idea of Licklider and other colleagues, to combine people with sharing computers. And we all know this, we had these terminals. And we had the extension of the internet, really, where people connected with files and people connected with people, for example, and other. Then we had a step to information. So I'm very schematically here. The step information, people to information, with all these social media and so forth and so forth. And of course, that was all thanks to the extension of TCP/IP with HTML and HTTP. Now we have the phase of data, and we use still the same methods. And the questions I would like to raise is that really the right way to do? Are we mastering the last phase, this fourth phase? And is that all? What comes next? Is there a new phase? Is there something that comes? Now, let me first go to the one last question. Are we mastering the last phase? There are many debates about this. My simple conclusion is no. And we heard about a few things already today. So if we just sum up the inefficiencies which we are confronted with, it's incredible. So you could say about 80% of the time of data science is wasted with data wrangling. I will not go into detail here. And if you look to Crowdflower survey, which is made in industry has the same numbers. And and we know, of course, that many data-intensive projects are not started. Note from my own institute. Many intensive data projects, industry speaks about 60% simply fail, and many people are excluded from data-intensive projects. So the major cost factors, if you look at these surveys, the major cost factors are bad data organization, bad data quality, and an increasing amount of complexity, of course, right? And yes, of course, there's also semantic processing, all the problems we know about. So there's no reason to assume an end of this dynamic development. Let me just refer to IoT and refer to these numbers which come from Cisco. We know this complexity and volumes will increase dramatically. And so everyone is calling for changes. We understand the data game really to know in which direction these changes should happen. I was inspired by my colleague Dimitris Kourias from biodiversity last week when he showed this diagram. I copied it. Christian Borgman from the US rephrased a well-known word from Coleridge. He said, water everywhere, but any drop to drink. You understand what I mean? Now, I don't know what the right word is, for data in this respect, but there is some mystery. There's so much data out there, data everywhere, but we don't yet really know how to bring this data, how to make use of it. Well, let me briefly go through a few project infrastructures to come to answers and to figure out where we are and what yours really would need in other comparable approaches. So call these infrastructures project-oriented infrastructures. We have many of them. I just show here something from material science I'm now involved in, and humanities I was responsible for. What is clear for these infrastructure is they have a clearly specified scientific case, mostly. So there are lots of interesting new questions which have been defined ahead. So for this, for example, can we find new types of categorizations in the endospace of compound materials? For this here, you could ask, can we better understand the evolution of languages, right? Having so much data hosted from everywhere, aggregated from everywhere. The reoccurring patterns for these infrastructures are definition of a common data core. You can do so in such projects, formats, metadata, semantics, and a huge amount of data aggregation and integration. Integration, and of course, in this world, is much more easier. We heard from Sergey and earlier. Often central harvesting over data products is done, and which also helps things going. So it's of centralized structure and has some advantages. And of course, the FAIR principles now help a lot in preventing silos, right? Which happened years ago. Now, there are domain infrastructures, and Ari presented his domain infrastructure. I was responsible for another one, but I will not go into detail here. The problem is there are no specific scientific cases. There's a range of scientific cases. So you can't have a specific interest or raise this specific interest of researchers. What you can do is raising awareness and fostering stepwise change. The reoccurring patterns are definition of domain standards and harmonics, but you are faced with high dynamics and structure the domain to increase reliability and quality. We heard about repositories and certified repositories. You can do a lot of metadata aggregation and model building and providing tools and much training. You can see here, my own community, for example, has created a workflow mechanism which naive people can use to do some work on textual data. And then you have generic infrastructures. They have a huge role. It's difficult for them to show their advantage for the scientists. They are mostly driven by IT considerations. Thus, they are far away from individual research disciplines and cases. But of course, we have some examples with huge impact, like TCP/IP, HTML, HTTP, cloud concept, and so forth. And of course, there are lots of examples where IT concept simply failed, right? Where they were not successful, where they did not hit the researchers and got attraction since the researchers didn't just see profit from the work. Well, the European Open Sign Cloud is basically a federation. And it seems to be a bit of all, right? So it has to be generic. It has to work with project infrastructures and domain infrastructures. So it's a huge enterprise. And as Damien already said, where to start? Where's the core? Where's the core, right? For such a federation scheme. Now, let me come back to my first early slide here. What comes next? I already said that we do not have, in my opinion, a sufficient approach for this fourth phase. What comes next, given the data trends? And let me share a few ideas with you about this. My feeling is, and I'm not the only one, that it says, we will have agents that are mediating between us and the huge amount of data. So in the IoT sphere, all these small devices create huge amounts of data. And it's impossible for a person, individual, to trace, to track of what data is available and so forth. Right? So you don't know what is new out there. So we need to have agents. You could call this scenario agent to data or data to data. We don't yet have a good term for this. Well, let me elaborate a bit on this scenario. What you, as a researcher, do is, of course, you specify profiles, metadata profiles, and you give task specifications. And the agent will run through the map for you and find data based on metadata. So does profile matching, and of course, based on types. I will come back to this type issue later. And what you hope is then that some process will be started automatically, and that the researcher will get some knowledge back. Well, this is futuristic. I think that's the way things have to go. Well, if we believe in this, what are the major challenges to make this happening? First, we have to have a stable domain of data for the next, let me say, century. Stable domain means, for me, we need to know where the data is, and we need to have clear identities for every bit of data. Because otherwise, we will not have a stable domain which we can rely on, which our machines can rely on. And I know Erik will go on this in a moment as well. So having a stable domain of data, we can start extracting knowledge from these data, from these large collections. And knowledge can be in form of statements, triples, if triples, or whatsoever, some knowledge in some form, annotations, which we can then work on. And of course, the next step is, if we have all this knowledge in whatever formal form, we have to integrate and exploit that knowledge. Oops. So, let me see. So, if we are going to do this, what are the major ingredients for such a domain? Well, some of them have already been mentioned. I think fair data, data is important. So data which is following the FAIR principles means also rich metadata which can be processed by machines. I will not go further on this since that has already been mentioned. We need trustworthy repositories. Also, that has been mentioned already. Trustworthy registries. We need to adhere to the digital object concept. That's my belief, and I'm not the only one here. And of course, we need to have a globally resolvable persistent identifiers, the unified DO interface protocol that makes that happen. And of course, flexible knowledge integration frameworks, like Sergey maybe announced that. Repositories have been mentioned. Just to mention, there are different views on repositories. But in a kind of IT view, you can look at repositories just as a large and complex structured collection of data. So a repository also should have a PID, persistent identifiers, and metadata, as everything else. We spoke about trust seal, so we need trustworthiness. Registries are a bit similar. They have a different function, different role. I will not go into details here. Normally, what registry do is they harvest some important metadata on data or on actors or whatsoever for services. Some of these also need to be trustworthy, since we need to rely on them. So one is the registry for persistent identifiers. We need to know that this machine works for the next decades with locations in them, and checksum maybe, and so forth. There are other registry types like metadata, which are not so crucial, since you can rebuild these kind of registries. Well, digital objects, I think I have 5 minutes, Ari, correct? Digital objects. What is a digital object? By the way, this notion of digital object goes back to Robert Kahn. Some of you may know him as father of the internet, and he produced already in 1995 and later then in 2006 a paper on digital objects. The Research Data Alliance State PFT group defined a core model which is very simple, but simplicity I think is very important. Digital object has a bit sequence, structured bit sequence, and these is stored in some repositories, can be many. A digital object has a PID, I should say associated with a PID, or referenced by a PID. It has metadata. Metadata can be of various types, of course, right? So it could be metadata for descriptive searching, could be metadata on rights, and so forth. And of course, metadata itself is a digital object. And you can aggregate digital objects to collections, which in itself, each collection is again a digital object. A very simple model, and as I said, simplicity counts. And as you can see here, those are basically compliant to a certain extent. what we need also is a globally resolved PID system. And I would claim we have it. There's a handle system, which is guided by the Donor Foundation, and this is ready machinery for all of us. And as you may know, Russia is part of that. So Russia is represented in the Donor Foundation, and so forth. I will not go into detail here. What is important is, if we believe that persistent identifiers are really persistent, since there is a resolvable system which is maintained, then we can make ourselves dependent on PIDs, not only on the strings, but also on attributes which we associate with the strings. So, and that's what more and more people are doing. We need a robust and stable global infrastructure for PIDs, and this system needs to be able to resolve PID, a string, into useful, as we call it, state information, which could be, where can I find my data copies? Where is the metadata? What is the checksum of the data? And so forth. Where is the rights information? Well, people are starting using this notion, and we use that term of binding capability of a PID system, which is very important, since after 10 years, you still have to know where's my metadata, or if you have the metadata, where's my data. So going to the Unified Digital Interface Protocol, which is one of the pillars, that, as you can see, comes close to what Sergey reported about, but less ambitious, I would claim. And again, things have to be simple. So what we see currently, looking at all these different infrastructures, being project-oriented infrastructures or infrastructures like Ari presented and so forth, they all have completely different types of repositories. What I mean is they use different storage hardware, operating systems, of course, they use different container types, then we call it container. Some use clouds, some use file systems. They use different data models. So some may use SQL databases, others may use no SQL databases, and so forth. They have different organizations. What do I mean with organizations? Mostly at this moment, and when I worked together with Damien and EUDAT, we found this very dramatically. Mostly, when you want to copy something from this repository to that repository, you know where maybe the data is, but you don't know where the metadata is. This metadata could be in a spreadsheet, or even, and we found that in code, some code, embedded in code. So the data organizations are horrible, different. Now, what could a DRIP help you? And you can see here, it's very similar to what happened with the internet, IP numbers, and the web. It could help integrating the different repositories. Some will need adapters, others will be native. What would they help? They would create a basic interoperability on organizational level between all these heterogeneous systems. And of course, that's exactly the situation for EOSC, for the European Open Science Cloud. So we see the Digital Object Interface Protocol as one core instance in this world to integrate things. It does not go so far as Sergey explained it, but it's simple. It's kept simple on purpose, as these other examples from history suggest. Now let me see. I have just one more slide, Ari, and then I'm finished. So, what do digital objects now help for us? They do abstraction. That means the users or the clients only have to deal with PIDs, PID record, PID information, and metadata. So logical representation of the data. They don't have to know how the different things are stored, which containers, in which models, and so forth. To a certain extent of processing, they just can use this kind of representation. So what you need is a layer of repositories which are functions or instances, service instances which offer some functions that can be used. And what you, this diagram, which was created by Larry Lennon from CNRI, does not include the processing level. What's also important with digital objects is that you can associate with all these digital objects, you can associate types. And then you can do something which we know very well about from digital object, from a object-oriented programming or abstract data type, that you can associate with all these digital objects, you can associate types so that automatic processing is made possible. I already mentioned that Robert Carr is very much involved, and he and his team just suggested the second version of his object interface protocol. I think it will become public very soon. And there's a group of people, institutions that are dedicated to implement this. I think that's all what I wanted to say. Maybe just a few references. So here, if you're interested, here you find one of the old papers from Robert Kahn. Here's the form model description. Recently, I wrote together with another pioneer of internet, George Strawn. I wrote a paper where we compared different infrastructures development. There's a paper that describes the group of people that are working on this model. And I also integrated a reference to the PID system which is out there. So it's based on the Swiss Donor Foundation. Thank you very much for your attention.
We have time for questions. Any questions from the audience? It doesn't seem so, but Peter, I have actually one question. You mentioned just briefly that this digital object model what you have is FAIR compliant. What do you mean by
Yeah.
that? I didn't really get this one.
Yeah. So I should maybe say FAIR compliant. It should I should maybe say it's facilitating or fostering FAIR. You know, it adds to each digital object, and digital object can be data, can be software, can be anything which is digitally represented. Associates a PID, so that's the first requirement of the FAIR principles. It lets you know where the metadata is, so it requires metadata. It doesn't say, you know, how this metadata should look like or so, but it says, you know, it has to have metadata. So it's also one of the FAIR principles. And of course, since digital objects also refer to the semantic level, so assertions, be it triples or whatsoever, are digital objects that also have identifiers. You see, having a domain of digital objects, I should say, facilitates the implementation of the FAIR principles. And maybe you should not say FAIR compliant. Okay. Maybe Erik will mention that. I'm currently writing together with Erik a paper on the relation between digital objects and the FAIR principles.
Okay. Any other questions? Okay, in that case, I have to say thank you for the effort. I hope that your voice gets better soon. And let's thank you once more and ask for the next speaker. Next speaker is Erik Schultes on GoFair. Just to make sure for the organization. After this, we are having a coffee break, yeah, so sure. It's not a problem that we are half an hour late.
I think so.
Okay.
So then
Проблема будет, сейчас кофе брейк, а потом сразу уже и вот это вот перенести. Они могли просто накрыть, и там все остынет.
Ну, сейчас я тогда, я схожу, узнаю. Окей.
Да тут не знаю, что.
Я сейчас не
Okay, let's start anyhow. Erik is the International Science Coordinator of GoFair International Support and Coordination Office. So, please.
Yeah, thank you, Ari, and thank you, Peter and Sergey, for the invitation to speak. It's my first time in Moscow, my first time in Russia, and for me this is a real high honor. I'm an American living and working in Leiden now for about 8 years. I came to work at the university doing research-related things in biomedical informatics, but this slowly evolved more and more into this idea of FAIR principles. And now I am, in fact, full-time at this organization called the GoFair International Support and Coordination Office. And this is an organization that's funded by Dutch, German, and French ministries. And it's an effort to find an accelerated pathway to implementation on the FAIR principles, but in particular focused on EOSC for now, but also with the idea that it could be a global infrastructure as well. And so I want to, I think the reason Peter asked me to speak here is to think of GoFair as a kind of a project in helping the field to converge onto implementations for the EOSC, to go from a cloud of possibilities to actually working implementations. So I'll try and make that argument or show you how we try to do that. But I think first it's important just to clarify what's the difference between FAIR and GoFair. So first, let's just talk a little bit about FAIR. This has already been discussed in the talks previous to mine, but I'll just try to emphasize. This is a quotation from this paper from 2016 that Damien had mentioned. It's already been referenced, I think, 750 times or something. It's crazy how much this paper was absorbed by the stakeholders. But this was the definition of FAIR in that paper. It was data, and by the way, services, that were F, A, I, and R for both machines and people. But these days, I often like to remind, especially non-technical, non-computer science audiences, that FAIR is really for machines. If it's for machines, then yeah, later on, maybe even for people. But just because of the sheer volume of data and the complexity of data, machines have to be doing this more and more. So it's trying to automate these processes for machines. Okay. And we've seen maybe snapshots of the 15 FAIR principles already today. But I will go through, just try to parse this out a little bit. If you look, these are really, on the surface, they're very computer science oriented, at least for non-technical people like myself. But as Peter just mentioned, principle F1 is simply asking for globally unique and persistent identifiers, which happens to match very well the work from digital objects. There's this idea of metadata, and again, for people who are not specialists in metadata, so that means for most of us, the FAIR principles are inviting us to really partition out our data and our metadata. And I think the FAIR principles are asking us to value metadata much more than we have previously. So principle F2 is talking about rich metadata. And it may seem kind of vague, but we're working on what this adjective means, what rich really means. I think in part it means community developed. So these are metadata that are coming from particular domains. It also means machine readable, machine actionable. But this is metadata for findability. And findability might be very different for astronomers and particle physicists than it is for biologists, for example. And there's mentions of metadata under the R concerning mainly licenses. Again, community standards have to be built into this, but also the provenance. So really understanding the value of the data, maybe the quality of the data, where does it come from, what is it based on, how can you trust it? Even details about the experiment or the instruments taking the data. And I separate that out from the actionable part of the metadata. So F3 is really just saying that there needs to be a link between your metadata and your data. It's a very simple idea, but of course it almost never happens, and it frustrates everybody and causes a lot of manual labor. And that the metadata are, in fact, data are going to be registered in an indexable resource. There's another mention of metadata in A2, that the metadata are accessible even when the data are no longer available. And again, for non-technical audiences, I say that in some ways, for FAIR, metadata is even more important than your data. Because your data set may be very large or very costly to maintain. You may have to delete it someday just because that's the realities of budgets. But FAIR is asking that your metadata persists forever, a kind of publication, so that the world knows what has happened in the past and can still find links to that area of research, even if the data are gone. And then lastly, just to really make the point that FAIR is for machines, this whole category of interoperability is asking for knowledge representation so that the computer can understand what's going on in the mind of the researcher, but then that there's also automatic protocols by which data can be accessed, and including the idea that some data may not be open or may never ever be open. For example, private patient data will just never be made open. So there's capabilities for building in security where needed. So that's just an overview. In some ways, the FAIR principles are very high level. They're not talking anything about technologies. On the other hand, in some cases, they're very precise in what they're asking for. There's not a lot of mystery here. It's hard to make this happen in a very general way, but the principles themselves are pretty straightforward. We took some time to, because it's kind of funny, even though this paper was referenced so many times, the FAIR principles themselves were just a box in that paper. They were never really described in any kind of detail. If you go to the GoFair website, you can find each of the FAIR principles with some more explanation behind them and links to examples and to resources, so you can see what we might have in mind when you try to implement these things. And then it's also nice, I think, to say what FAIR is not, to really help get a handle on what the original intent was. So FAIR is not a standard. These are principles to which many different standards could be used in implementation. And so the question is, how do we go about deciding as a community on which implementations we're going to go with? And by the way, this was no accident, right? That we were advised from people who had experience with the origins of the internet itself to keep this at a very high level. These are principles, not standards. So FAIR is not equal to semantic web, so it's not just trying to deploy semantic technology or a kind of semantic technology. It's more than that. FAIR is not equal to open or free, and I think we've been through that today. There are lots of examples of open data right now that are not fair. There's lots of examples of data that could be perfectly fair, yet still closed. And in fact, there are examples of data that will never be open. And then I mentioned this as well. In my view, I think also in the view of the co-authors on that paper, FAIR does not directly prescribe anything about data quality or trustworthiness. I know there's already people, organizations that are trying to impute some kind of ethics or responsibility into the FAIR principles. These are really just about machine actionability for FAINR. However, there is a strong belief that if your data were fair, that it would lead to, or you could make better inferences about data quality, trustworthiness, because you would have access to this provenance information, and you would just have this richer metadata by which you could trust the data. And by the way, there's no reason why you still can't create elements, metadata elements that could plug into your FAIR metadata that could in fact certify through some trusted organization trustworthiness or quality. So you can certainly go that route if you want to, but it's not built into the FAIR principles, and it's not built in by design. The FAIR principles are about this machine actionability and not about trying to get into the very difficult issues about data quality. Okay, so that was FAIR. So what about GoFair? First off, it's an acronym. The GO is also an acronym. It stands for Global and Open. So its vision is broader than Europe. It's viewing a global infrastructure of fair data and services. I mentioned it was already that we were initiated by ministries in these 3 countries. And the name of the office, the fact that we are support and coordination office, is also something that was discussed quite a bit. I would say my job now is, my job description is that I do nothing, but what I do is I support and coordinate others who do. So I'm not implementing right now, I am supporting and coordinating the many different stakeholders that are trying to do these things. And so we see GoFair as a way to take the FAIR principles and go to FAIR implementation, so try and accelerate that path. And we think of it as a bottom-up, stakeholder-driven implementation strategy. And we start with components for EOSC, but the vision is much larger for this Internet of Fair Data and Services. And I'll just replace these implementations. I took this picture from Simon's report this morning when he was talking. I thought, well, he was talking about fair data ecosystems. And this includes policies, it includes standards, it includes organizations, identifiers. All of these things are in the domain of GoFair as well. So, and another view of this emerging infrastructure, this is coming from Baron Mons, but he sees, we can represent this as trying to build an infrastructure where tools and data and compute resources can somehow automatically find each other and route. And if you look at it, this is a little bit like the hourglass that Peter showed, except it's a 3-way hourglass. This is the waste of the hourglass. And there's something happening here. Maybe we call it a digital object interface protocol, but that's the discussion that Peter and I are having right now. We're trying to flesh out how FAIR relates to digital objects. One more snapshot of this, kind of looking at the timeline. This whole idea of FAIR was coming out of a Lorenz Center workshop in Leiden in 2014. Soon after, there was a Dutch project to try to build what we call reference implementations of the FAIR principles. So I myself was involved with this DTL project, and we built something called the FAIR Data Point, and we built some training programs, and we have these bring your own data events where we go to a biologist who has a spreadsheet, and in 3 days we help them to make their data more fair. They put it on a FAIR Data Point. And of course EOSC came along, and Damien was very helpful in showing us what that looks like, how the relationship is. So a lot of rapid uptake. It felt like there was a need for something like GoFair, and the idea is that we tried to drive convergence towards some kind of implementation. This is the paper that Peter had just mentioned that he wrote with George Strawn, trying to look at revolutionary infrastructure, common patterns in revolutionary infrastructures. So there's this idea, you have this vision, data should be interoperating automatically in the world. There's an explosion of prototypes that follow, and many of these prototypes are very kind of focused on very particular problems. At some point, certain technologies and organizations begin to attract others for a variety of reasons, and then at some point you get the commitment of usually a few key influential organizations to a particular implementation. Then we say, oh, this new infrastructure has been born and there's exploitation. And Peter was obviously making the reference as well to TCP/IP as a kind of an attractor, pulling together the community. In fact, it was commercial interests that actually led to the convergence and exploitation of a research infrastructure that became the internet. The strategy that you can extract from this history is that you need a minimal standard, voluntary participation, so there's no top-down command that you have to use a certain standard or technology. It's all voluntary, but once you get a critical mass of players, the rest of the participants will give up and say, hey, so for many of us now, we use the internet without really debating TCP/IP. It's over. We're happy to use it. Even many of us don't even know we're using it. And so we can map that same 4 or 5 phases of that history onto what we're trying to do in GoFair. GoFair was designed explicitly to try and drive convergence along this model. And so here's one way this might look. I'm listing a bunch of organizations and projects that I had personal experience with myself. This list could be probably 5 times longer. There's many organizations that I'm leaving out. But these are the things that I was familiar with. GoFair is built, structured on these 3 pillars of Go Build, Go Train, and Go Change. Go Build is centered on technology. Go Train is trying to build in people the knowledge and skills and awareness necessary to launch this kind of infrastructure. And Go Change is really trying to look at the very highest levels for systemic change in funding organizations, for policymakers, research organizations. So in the first part of this year, we were setting up the office. And now I think it's very exciting. We're seeing the emergence of over 20 what we call implementation networks. These are voluntary consortia that are coming together to, we would say, build a component of the Internet of Fair Data and Services. The implementation networks in orange are technology-centered. The purple ones are, we have 3 implementation networks for training, and we have at least 2 that are explicitly for Go Change. Everything in blue is representing implementation networks that are more about domain specialties. So the American Geophysical Union for Earth and Space Sciences, climate centers, the CDataNet. I'm looking for some organizations in solar physics, and then maybe we have 4 elements, 4-element cluster of implementation networks. But you see a variety of domains and technologies, training applications. What we expect to see bubbling up out of this phase are elements that might lead to convergence. And how much time do I have?
You still have 5 minutes.
Okay, good. So I would just, in the next few slides, I will just show you highlights from some of these prospects that we think are promising points of convergence in the community. All right, so this is what I just showed on the other side. We have these thing called fair data points. This is one of the reference implementations we built in the Dutch project that I mentioned. Basically, this is it's like a linked data platform. It's a W3C standard, but this is a way of building machine-readable metadata in a hierarchical way. It sits above your data sets. You access and you query this metadata through simple GET calls, World Wide Web protocols. The structure of this vocabulary is following the data catalog, another vocabulary from W3C. And what we have is we have this high-level thing called a fair data point. Within a fair data point, you have one or many catalogs. Within a catalog, you have one or many data sets. And within a data set, you can have one or many distributions. That's DCAT vocabulary. But the way Peter was talking about repositories and collections, you can see these, I think, as different levels of aggregation. Each of these levels obviously could have their own unique identifiers. So we're building in a machine-readable, persistent identified set of objects here. And in this example, I'm just showing, here's a data set, it's a text file. The same data set is written as RDF, so we distinguish that as being two different distributions of the same data set. Here's a third data set, or here's another data set that's a CSV file. There's other data sets that are image files. And the idea is that by querying a fair data point, a computer could drill down until, in this case, you could actually get to a particular row and column of a data set. You would know what that number is, that it's a blood pressure reading of a patient that has certain metadata. You would know the units of that reading because everything's machine readable to the bottom. If you don't have the capability to express your data in RDF, you could put it as a text file, and at least the computer will know where to get to it. The human may have to take over at that point. But anyways, it's not to say that fair data points are somehow here to last, or that this is the best way of implementing FAIR, but it's just a way that we were able to show the implementation of many of the FAIR principles just by cobbling together existing resources. We didn't invent anything new to create fair data points. And I know as part of EUDAT, we've had a project where we're putting fair data points as a top layer on top of EUDAT repositories so that certain data elements can be expressed, can be sent up to the fair data point, and then be exposed that way. So it's a way of verifying existing repositories without having to change them very much. There's also been a little discussion today about fair metrics, or metrics for fairness. About a year and a half ago, a group of us launched a project where we were trying to build not just metrics, but we built a framework in which metrics can be designed. And this was because we knew that at the metadata level, at the community level, there would be an enormous amount of different metadata elements that would be important for different communities. So we wanted to build a framework by which everyone could build metrics that could be machine actionable and built in to, for example, your fair data point. We've run hackathons where people come to the hackathon with their data resource. We spend the first half of the day using the FAIR metrics to evaluate the level of fairness of their repository. And then we go for 24 hours where they can hack their way to increase fairness. By the end of the second day, we can do another evaluation using the FAIR metrics, and you can see a differential in the scores. And then we can have a competition to see who can be more fair in a 24-hour period. What the FAIR metrics allows you to do is to get very precise about what it is you mean by fair, and then it helps you to even start prioritizing how it is you would want to go about the verification process. Because it's expensive. In many cases, it could be expensive and difficult. So the FAIR metrics are just a way to help us resolve what needs to be done. And by the way, because they're machine actionable, they can ultimately be certifiable as well. So a trusted third party could launch a program where they actually certify the fairness of things. And then just a couple of things. The FAIR metrics prompts the user to be very critical about how fair their resource is and what they need to do to comply to the metric. The FAIR metrics, therefore, begin to start asking the community to solve challenges for themselves. The communities out there, whatever it is, a geophysics community, a rare disease community, they have to start answering community-level questions about identifiers, about metadata, about persistence policies. And so from the metrics, you automatically get a list of community challenges. I've been able to formulate 29 community challenges so far. We're trying to get this into a publication as soon as we can. But the idea is that within 29 steps, anybody could be fair, although those 29 steps could be very difficult to do in practice. And I'll just mention one other thing here, so I don't want to go too long. But next Monday, at the GoFair office in Leiden, Peter Wittenburg and I are going to launch what we call the Metadata for Machine workshops. And this is, we're planning a series of workshops by which organizations can come, so different communities can come, and formulate for themselves some of the decisions that they need to make on these community challenges, and to commit to certain metadata standards that will enable their community to become more fair. So it's just a little bit more of a systematic way to start guiding different communities to start making the decisions that they have to make to be more fair. There's other things I could talk about, but I think I will leave it there. And I don't know if there's time for questions. I'm happy to.
Yeah, there is still about 4 minutes time for questions.
So I have a question. You said that fair it is not semantic web, it is not equal to semantic web. But what exactly you can find in fair that doesn't exist in semantic web?
Yeah. So I think the way of answering that question might be that there could very well be semantic webs out there now that I can't find. I don't know that they're there. So they're hard to query, they're hard to access. Yeah? Because you're thinking like linked open data cloud maybe. Yeah?
Yes.
So yeah, so I think for me the idea of when you look at the FAIR principles under I, I think this was a monumental effort to basically try and abstract in 3 simple principles what we all know as semantic web technology. So we're talking about knowledge representation languages. But the I is only one component of the FAIR principles. So there's things like licensing for reuse. There's things like community standards, right? There's access protocols that may not be described. I don't know how to maybe actually get to or access that data. So it's simply just trying to, I think one way of looking at it would be to say, having perfectly good semantic data augmented with richer metadata. I think that's how you would verify semantic web.
Could you please give us an example of fair data which is closed and will never be open? And also, if it is closed, how do you know that it's fair?
So I think the example that I run into all the time is because I usually, or I often will be talking with biomedical researchers, and it's really patient data. So any kind of medical data or patient data has extremely severe privacy restrictions, and the organizations that are custodians of that data are fiercely protected. It'll never be open. Now the other question of how do I know it's fair? It's not a question of whether I know that their data is fair or whether or not I even really care that their data is fair. It's really a question for them. And they're saying, hey, we have this huge amount of data and we would like to get more value out of it. There may be a world of fair data out there. Maybe we should try to connect to it.
Any other questions, comments? Okay, thank you.
Okay, thank you.
In that case, I think we close this session.
Yes, probably. And